Here are more data science vocabulary terms with examples. Logistic regression, a statistical method used for binary classification, modeling the probability of a binary outcome. Example: predicting whether a customer will purchase a product, yes/no, based on their demographic information. Bias, a systematic error or deviation from the true value in data analysis or modeling. Example: if a temperature sensor consistently reads 1 degree higher than the actual temperature, it has a bias of +1 degree. Variance, a measure of the spread or variability of data points in a dataset. Example: in a dataset of student test scores, high variance indicates that scores are widely scattered, while low variance indicates scores are close together. Feature extraction, the process of reducing the dimensionality of data by selecting or transforming relevant features. Example: using a text-to-vector technique like TF-IDF to convert text documents into numerical features for machine learning. Gradient boosting, an ensemble learning technique that builds multiple decision trees sequentially to improve model performance. Example: applying gradient boosting to improve the accuracy of a model predicting customer churn for a telecom company. Time series forecasting, predicting future values based on historical data points collected at regular time intervals. Example: forecasting monthly sales for a retail store based on past sales data. Churn rate, the percentage of customers who stop using a product or service over a specific time period. Example: calculating the monthly churn rate for a subscription-based streaming service. ANOVA, analysis of variance, a statistical technique used to analyze differences among group means in a dataset. Example: using ANOVA to determine if there are significant differences in the average salary among employees in different departments. Hyperparameter, a parameter whose value is set before the model training process, affecting the model's learning process. Example: the learning rate in gradient descent or the number of trees in a random forest are hyperparameters. Deep reinforcement learning, a combination of deep learning and reinforcement learning used to solve complex problems by training agents to make sequential decisions. Example: training an AI agent to play complex video games like Dota 2 or StarCraft 2. Sensitivity and specificity, evaluation metrics used in binary classification models. Sensitivity measures the ability to correctly identify positive cases, while specificity measures the ability to correctly identify negative cases. Example: sensitivity helps evaluate how well a medical test detects the presence of a disease, while specificity measures how well it correctly identifies healthy individuals. K-nearest neighbors, KNN, a simple machine learning algorithm used for classification and regression tasks, based on the similarity of data points to their K-nearest neighbors. Example: classifying a new email as spam or not spam based on the majority class of its K-nearest neighbors in a labeled dataset. LSTM, long short-term memory, a type of recurrent neural network, RNN, architecture designed for sequential data analysis, such as time series and natural language data. Example: using an LSTM network to predict stock prices based on historical trading data. Cross-entropy loss, a loss function used in classification problems that measures the dissimilarity between predicted and actual class probabilities. Example: calculating cross-entropy loss to train a neural network for image classification. Bagging, an ensemble technique that combines the predictions of multiple models, often decision trees, to reduce variance and improve model accuracy. Example: building an ensemble of decision trees and combining their predictions to create a random forest model. One-hot encoding, a technique used to convert categorical variables into numerical format, creating binary, 0-1, columns for each category. Example: encoding categorical features like color, red, green, blue, into one-hot encoded columns for machine learning. API, Application Programming Interface, a set of rules and protocols that allows different software applications to communicate and interact with each other. Example, using a weather API to fetch real-time weather data for a mobile weather app. Batch processing, the practice of processing data in large, discrete chunks, batches, rather than in real time. Example, analyzing a day's worth of e-commerce sales data each night to generate reports and insights. Feature scaling, the process of standardizing or normalizing features in a dataset to ensure they have similar scales, preventing some features from dominating others during modeling. Example, scaling features like age, in years, and income, in thousands of dollars, to have similar ranges.